So now we are going to see different methods to find the correlation. So there are 5 methods in standard, right? In general, we are having 5 methods, right? First is scatter diagram method. Second one, the famous one, the important one, Pearson's coefficient of correlation, or covariance method. Both are same. And two-way frequency table, bivariate correlation method, rank method, and concurrent deviation method. Right? These are the 5 standard methods to find the correlation coefficient. So first, Pearson's coefficient of correlation. So here method 1 in Pearson. So deviation from the mean or average method. That is the method. Deviation from the average. Right? So deviation means subtraction from the average. Right? We'll see. Correlation coefficient between two variables x and y is given by x is a random variable. It's contain x1, x2, xn, right? And y is the variables contains y1, y2, yn. Let it be, right? So r x comma y, which is equal to small r, that is the notation of the correlation coefficient, which is equal to summation x minus x bar into y minus y bar divided by root of x minus x bar square into y minus y bar square. So here x bar is the mean average of xi's, summation xi by n, and y bar is the average of yi's, that is summation yi by m, right? Let it be small x is equal to x minus x bar and small y is equal to y minus y bar. The formula is very easy to remember. R, which is equal to sigma xy, small x into small y, by root of sigma x square into sigma y square, right? So next, second method, assumed mean method. So previous method, deviation from the mean. Deviation from the mean means x minus x bar, right? Deviation from x bar, deviation from y bar, y minus y bar, right? Here assumed mean method. See, instead of finding the mean, instead of finding x bar and y bar, we just assume one number from the all x. We have to choose one number from all x, and similarly we have to choose one number from all y's, and related to y, related to x, right? That is called assumed mean method. We have to assume the mean instead of finding the mean, right? So same like before, we are using the shortcut method for this assumed mean method. So r is equal to n into sigma dx dy minus sigma dx into sigma dy divided by root of n into sigma dx square minus dx the whole square into root of n into sigma dy square minus sigma dy the whole square. Here capital N is always summation of the frequency. So everything will be given in the problem. So x1, x2, x3, xn they have given, and y1, y2, y3, ym it will be there. The data are already available in the problem. So related frequency also given, f, related to both x and y. That is called f frequency. Summation of all frequency is called capital N. N is equal to summation f. And small dx, small dy is the deviation from the assumed means, right? So deviation from the mean means x minus x bar, that is xi minus x bar, right? Here xi minus a. A is the assumed mean from xi's, and similarly dy, which is equal to yi minus b, that is assumed mean from y, right? Yi minus b. Sometimes instead of a we use the notation a suffix x. Similarly for y we use a suffix y, assumed mean, that is why capital A. Ax means assumed mean from x, ay means assumed mean from y. So deviation means difference, that is what minus we are putting, right? So here the formula n into summation dx dy minus sigma dx sigma dy by root of n into summation dx square minus sigma dx the whole square root of n into sigma dy square minus sigma dy the whole square. That is why this is called assumed mean method. Assumed mean, we are taking the deviation. Deviation from the mean, first method, deviation from the assumed mean, second method, right? A is any number related to x and B is any number related to y. Method 3, covariance method. So covariance means we need to find the covariance between x and y. Suppose if covariance are given in the problem, you have to use this formula, right? Covariance of xy by sigma x sigma y. Sigma x sigma y is nothing but standard deviation of x and y respectively. So covariance of xy formula is 1 by n sigma xy minus x bar y bar whole divided by root of 1 by n sigma x square minus x bar square into root of 1 by n sigma y square minus y bar square. So sometimes it is denoted by r suffix xy, right? Now for the bivariate, right? So two variables are given, x and y, f of x comma y. The function is with the two variables f x comma y, right? In that case, we are using this formula, r is equal to n into sigma f dx dy minus sigma f dx into sigma f dy whole divided by root of n into sigma f dx square minus sigma f dx the whole square into root of n into sigma f dy square minus sigma f dy the whole square. N is, I already told you, summation of the frequencies. Dx is the assumed mean or assumed deviation from the assumed mean or deviation from the mean. Whatever it is, better you have to take assumed mean. That is the shortcut method. Dx minus dx is equal to xi minus v, dy which is equal to yi minus v. Sometimes we have to take the dx which is equal to xi minus a by h. H is the interval length. Sometimes you will take, that is the very easiest method, right? So dy which is equal to yi minus b by or yi minus ay by h. H is the interval length of the y's. Then h first term dx in dx xi minus a by h. H is the interval length of xi's. Right? If x1, x2, x3 are in equal interval, you take the difference. Right? Equal interval, that is h. Similarly for y. Suppose if it is in the continuous, that is 1 to 10, 10 to 20, then you take the interval length, that is h. Right? Take the midpoint, then choose the interval. Better. So in that case, continuous case, we have to choose the midpoint of the intervals 1 to 10, 10 to 20, like that. Choose the midpoint and difference between xi minus 1. That difference, that is called h, right? So assumption underlying Pearson's coefficient. What are the assumptions to using Pearson's coefficient? First, the variable x and y under study are linearly related. So first relation, linear relation. Scatter diagram of the data will give you a straight line. Linear relation means linear means straight line, right? Cause and effect relationship exists between different forces operating on the items of the two variable series. For example, there cannot be any correlation between the following relation: the series of weight and income of individual over a period of time. So there is no correlation, right? Related to weight and income, there is no relation. Weight and height, there is a relation, right? Income and expenditure, there is a relation, but there is no relation, right? The series relating size of the shoes and intelligence based on the shoes we are wearing, related to our intelligence, no, nothing, right? So there is no relation between size of the shoe and intelligence, right? Third one, normality, normal, right? Standard one, right? So merits and demerits of coefficients. So merits, this gives the direction as well as the degree of the relationship between the two variables. Second one, this helps to estimate the value dependent variable from the known value of unknown variable, right? Third one, it is easy to calculate, right? The merits assumption of linear, only we are assuming a linear relationship. Other than that, we cannot use this, right? Sometimes it will take time. Suppose if you are having big data, it will take time to calculate. It will affect by extreme values. So maximum minimum values, it is affected by the maximum minimum values, definitely, right? Because we are using mean, right, or assumed mean, right? Standard error of coefficient of correlation, right? The standard error of coefficient of correlation is given by sometimes standard error SE of R. R is the correlation, which is equal to SE suffix R, which is equal to 1 minus R square by root n. R is the coefficient of correlation. N is the number of pairs of observation. Number of pairs means x, x1, x2, x3, xn, and y1, y2, y3, yn. So equal number of pairs. So in x also x1, x2, xn up to y also y1, y2, yn, right? Equal number n. We are choosing the n. Probable error of coefficient of correlation. Probable error of coefficient of correlation is given by PE of R, which is equal to PE suffix R, which is equal to standard result 0.674 by into standard error of the correlation. First we have to find the standard error of correlation, then we have to multiply with 0.6745. That is called probable error. So standard error of, we know the formula, 1 minus R square by root n. 0.6745 into 1 minus R square by root n. R is the coefficient of correlation. There are so many methods. Standard method, 3 methods are there. From one, we have to find the R, right? Range of population coefficient of correlation. So next range. With the help of error, right? We can find the range in which the population coefficient of correlation, that is rho, lie, right, by using the following relationship. So probable error, we are choosing the probable error. Rho is equal to R plus R minus probable error of R, right? To check the significance of R. So if R is less than 6 into probable error, then R is not significant. That is, there is no relation between the given two variables. If R is greater than 6 into probable error, then R is significant. There exists a relation between given two variables. Next, coefficient of determination. The coefficient of determination are R squared method. This is called capital R square method. Is the portion of the variance in the dependent variable, that is predicated from the independent variable. The coefficient of determination R square method, this is called, is the proportion of the variance in the dependent variable, that is predicated from the independent variable, right? It indicates the level of variation in the given data set, right? The coefficient of determination is the square of the correlation, right? Thus it ranges from 0 to 1, right? Coefficient of determination is the square of correlation, right? Because correlation lies between -1 to +1. So squaring -1, you will get +1 only. So it is lies between 0 and 1. Coefficient of determination, which is equal to R square. That is why it is called R square method, right? Capital R or small r square method, both are same. Coefficient of non-determination, it is a statistical measure of proportion of the variation in the dependent variable that is not explained by independent variable, right? It is calculated by subtracting the coefficient of determination from 1. So coefficient of non-determination is 1 minus R square. First you have to find the R square, then you have to find 1 minus R square. That is called coefficient of non-determination. So procedure to find, right? Method 1, deviation from average mean method. So calculate x bar. I already told you that sigma x by n, y bar is equal to sigma y by n. Subtract the mean from every values of x and y, xi minus x bar and yi minus y bar. Multiply these subtracted value, so xi minus x bar into yi minus y bar. Then square this subtracted value, x minus xi minus x bar square, find y minus y bar square. You have to make a table and find all these things, right? Sum this multiple the value sigma x minus x bar and y minus y bar, right? Sum of the squared value sigma x minus x bar square and y minus y bar. Whatever in the formulas here calculating, we are finding separately in the table, right? Then we have to put it in the formula. That's all. That is what we are finding, all those things. Then substitute in the formula. So interpretation. So from this range, so 0.09 to 1, very high positive. If it is negative, then very high negative. 0.7 to 0.9, high positive. Minus 0.7, 0.9 means high negative. 0.5 to 0.7, moderate positive. Similarly, for the negative, it will be minus. 0.3 to 0.5, low positive. If it is in the minus, low negative. 0 to 0.3, negligible correlation. So correlation, there is no correlation, almost both are same, right? So problem based on that one, deviation from average. So first problem, calculate the calculate and interpret the correlation coefficient of the two variables below. So given A, B, C, D, E persons and 17, 15, 19, etc. and also height also given 150, 157, 4, etc. So here number of persons A, B, C, D, that is n is equal to 5 for both x is hand and y is height. So persons A, B, C, hand, that is x, right? Let it be x, 17, 15 in the tabular columns. So height on the third column. So first to find the summation. So a hand, that is x, right? Sigma x, adding all those things you will get 89. Similarly height, let it be y, capital Y or small y, sigma y is equal to 820. Next you have to find x minus x bar and y minus y bar. So first x bar is 89 by 5, correct? And y bar is 820 by 5, right? That is x bar, y bar. Then you have to subtract each and everything. 17 minus x bar, 15 minus x bar, 19 minus x bar, 17 minus x bar, 21 minus x bar. That is called x minus x bar table, right? Similarly, y bar is sigma y by n, that is 820 by 5. So you calculate the value, then you have to subtract from each and every one. Y minus y bar, that is 150 minus, right? Minus y bar, 154 minus y bar, 169 minus y bar, 172 minus y bar, 175 minus y bar. That is x minus x bar, y into next column y minus y bar. Then multiply x minus x bar into y minus y bar. That is column number third and fourth. 3 into 4. You will get the fifth column. 11.2, 28, 6 minus 6.4, 35.2. So adding all those things, you will get sigma x minus x bar into y minus y bar, that is equal to 74. Next you have to find the x minus x bar square, that is column 3 square, right? Square of column 3. So minus 0.8 square, 0.6, next 7.8, 1.4, 0.6, 10.2. Adding all those things, you will get summation x minus x bar square, that is equal to 20.8. Then last one, fourth column square, y minus y bar square. So 14 square minus 14 square, 196, 10 minus 10 square, 100, 5 square, 25, 8 square, 64, 11 square, 121. Adding all those things, sigma y minus y bar square, which is equal to 506.0, right? Then average mean, this is what mean, right? We have to use this one 17.8 and 164 there. Next you substitute in the formula. R is equal to summation x minus x bar into y minus y bar by root of sigma x minus x bar square into root of y minus y bar square. From the table we can put the value 74 by root of 20.8 root of 506. You will get 0.7. So the formula gives us the correlation coefficient is 0.72, which is high positive, right? We have the table, right? From that we are giving the interpretation, meaning that the data set as height increases, so does hand height, right? So hand is also increasing, right? Height is decreasing, hand is also decreasing, hand height also decreasing. That's all. Next problem, calculate and interpret correlation coefficient of the two variables below. Similarly here they are on weight and blood pressure BP. So same procedure. So we are finding all those things. That is x, y. X is weight and y is blood pressure. So summation of x, summation of y, that is 874, 734. Then we are finding x bar and y bar. X bar is equal to sigma x by n. So 874 by 5. Similarly, y bar is equal to sigma y by n, that is 734 by 5. Then subtract from each x minus x bar. 150 minus x bar, 169 minus x bar, like that you will get minus 24.8, etc., etc., 25.2. Similarly, y minus y bar, minus 21.8, minus 16.8. Then next to find squaring the third one. Third and fourth, multiply third and fourth, 3 into 4. So next columns x minus x bar into y minus y bar, 540.6 and 94.4. So summation of all those things, you will get summation x minus x bar into y minus y bar is equal to 836.8. Similarly, third square, column third square, 615, 33.6. Then adding all those things, summation x minus x bar square is equal to 1310.8. Then column fourth square, y minus y bar square, 475.2, 282.2, etc. So summation of all those things, summation y minus y bar square is equal to 1434.8. So substituting in the formula, and values are from the table, so you will get 836.8 by root of 1310.8 root of 1434.8, that is equal to 0.64. So here also positive correlation, right? Next problem, coefficient of correlation. Next finding. So here x series, y series they have given, and sum of square of deviation of mean also they have given, arithmetic mean they have given. So they have given directly everything, right? Instead of variables they have given number of items, that is n1, n is given, right? Number of items for x, number of items. Arithmetic mean x bar, y bar, that is given. Sum of the squares of the deviation, that is sigma x minus x bar square, sigma y minus y bar square, that is also given, that is equal to 136 and 138. Right? So now n that is given, x bar, y bar, right? Everything given, right? So sigma x minus x bar into y minus y bar, that is what given, that is summation of product of deviation x and y series from the respective arithmetic mean, that is equal to 122. That is called summation x minus x bar into y minus y. So substituting in the formula all the values, so you will get 0.8905. Next problem, given correlation R between x and y is equal to 0.8, then summation of x y is equal to x into y is equal to 60. So standard deviation sigma y of y is 2.5 and sigma x square 90, where x and y are the deviation from the respective means. So here small x means x minus x bar, small y means y minus y bar. Find the number of items. So here we have to find number of items, how many x's and y's, right? So Rxy is equal to 0.8, sigma x into y is equal to 60, that is sigma x minus x bar into y minus y bar. sigma y, standard deviation of y is equal to 2.5. Sigma x square, x minus x bar square is equal to 90. So here that is what given. So sigma y formula we know, standard deviation formula root of sigma y minus y bar square by n, that is equal to 2.5. So root of sigma y square by n, which is equal to 2.5, that is equal to, so here in the notation small sigma y square, y means y minus y bar square, that is why we replaced sigma y square, root of sigma y square by n is equal to 2.5. Therefore root of sigma y square is equal to root n into 2.5. So we know correlation formula, sigma xy by root of sigma x square into sigma y square, right? That is the formula. So substituting the all values, 0.8 which is equal to sigma x into y 60, that is given. Then sigma x square, that is also given, 90, root of 90. Then sigma y square, root of sigma y square is root n by 2.5, that is equal to, so taking root 10 to the left hand side, which is equal to 60 by 2.5 into 0.8 into root 90. So root n is equal to 24 by 0.8 root 90, squaring both sides, so you will get 576 by 57.6, that is equal to 10. Thanks.